All right, let's tackle one of the biggest questions imaginable. Is the universe infinite? It is a truly mind-bending concept. But what if I told you the problem isn't the universe itself, but the word we use to describe it? Let's dig into why infinite might be more of a story than an actual measurement.
I mean, we've all heard this, right? Physicists, science communicators, documentaries, they all love to throw around this idea that the universe could just be infinite. And it's an amazing thought, isn't it? This picture of endless stars and galaxies stretching out forever.
But hold on, here's the twist. What if that statement, the universe is infinite, isn't a scientific fact at all? What if it's actually a sign that our language has completely failed to keep up with the physical world? Okay, so let's start with the story we all know. When we think of infinity, we usually just picture something that goes on and on and on. It's a simple idea, feels intuitive. But here's the thing about physics. An idea can't just feel right. It has to work. You've got to be able to use it in an equation. And that right there is where this simple idea starts to completely break down. And this really gets to the heart of the argument. The problem isn't finding the right answer to the question. The problem is we're asking the wrong question in the first place. The word infinite, you see, it just doesn't have a functional definition when you try to apply it to the actual physical universe. So here's the crucial point. Infinity isn't a number. It's what's called a narrative descriptor. You can think of it as a placeholder. It's the word we pull out when we hit a scale so ridiculously vast that it becomes, well, simply unknowable. So it's not a measurement. It's basically an admission that we can't measure it. And here you can see that disconnect laid out so clearly. The casual claim that the universe is infinite is, in reality, just a story about a scale we can't know. The idea that it goes on is just a fuzzy, imprecise way of talking. And the belief that infinity is some kind of measurable state, nope, that's just mistaking a symbol for something you can actually calculate. You know, for any concept to be truly useful in physics, you have to be able to do math with it, plain and simple. You have to be able to plug it into an equation and have that equation make sense. And this is exactly where the concept of infinity just completely falls apart. So, as numbers get bigger and bigger and bigger, they eventually cross a kind of threshold. They enter what the source calls a vague area of unknowable size. And at that point, they stop behaving like real numbers and just become, well, meaningless symbols. Let's see exactly how this works. We'll start simple. 2 + 2 = 4. The math is solid, concrete. It works perfectly, no problem. Now let's go huge. 1 trillion plus 1. The number is absolutely enormous, but the rules of math still apply. We can calculate the exact result. It all still works. But now we hit a wall. What is infinity plus 1? I mean, is it a little more infinite? Is it the same? The question itself is just nonsense, because you can't perform arithmetic with a concept that isn't a number. The math just stops. So when a value becomes a symbol like infinity, it loses 3 critical properties. First, identification. You can't point to it as a specific concrete value. Second, comparison. It's impossible to say if one infinity is bigger than another. And third, arithmetic. As we just saw, you can't calculate with it. Without these 3 things, the term becomes physically meaningless. Now, this loss of mathematical function leads to a really surprising paradox, where 2 words that we think of as total opposites, infinite and finite, actually start to mean the same thing. Just look at these 2 claims. If the universe is infinite, we know it's a value that breaks math. But what if the universe is finite, but just so astronomically large that its size is beyond our ability to ever measure? Functionally, it's the exact same problem. That value is so big, it enters that same vague area where it can't be identified, compared, or calculated. Both statements fail in the exact same way. So what this means is that from a functional mathematical point of view, infinite and finite effectively become synonyms. They're both just placeholders for a scale that's beyond our numbers. They're really just different ways of saying we don't know. And this is a serious issue. Using a term like infinite as if it were a fact is a failure of scientific rigor. It's presenting a symbolic story as an established truth when it's anything but. So if these big, grand terms are basically meaningless, what's the alternative? How should we be talking about the cosmos with more honesty and more precision? Well, the solution is to ground our claims in what we can actually observe and measure. We have to move away from using these literary, symbolic terms and focus instead on what the data can actually support.
So what's the new, rigorous approach? The only scientifically honest statement we can make about the universe's total size is this: the universe is bigger than the visible universe. I know it's not as poetic as infinite, but it has one massive advantage. It's verifiable, it's precise, and it's true. This leaves us with a really clear framework for how to think about this. First, acknowledge the limits of numbers. Second, prioritize math that actually works. Third, always distinguish symbols from actual sizes. And most importantly, limit our factual claims to what is actually observable. So this leaves us with a final, powerful question. The next time you hear someone describe the universe as infinite, maybe the best response isn't to agree or disagree, but to simply ask, are we talking about a number, or are we telling a story? Thanks for joining this explainer.